Can you fit all the numbers from 0 to 9 into a frame? This is a puzzle from the UK in 2013. It looks simple, but it's actually quite difficult. As you can see, you can easily put the first 6 or 7 numbers into the frame, but eventually 1 or 2 numbers will no longer fit. The reason is very simple. For example, 0 can be placed this way or in a different direction. It can be combined with 1, and it can also be combined with 7. You can continue to place other numbers around them, but there's a tricky part. Different numbers can be placed in the same position or in other places. It's hard to figure out where these numbers should be placed. The puzzle has only one correct solution. Find the exact placement and orientation of each number. We put 3 here. Now there are only 2 numbers left. We put 4 like this here. Now the space can perfectly accommodate 5. Everything fits perfectly. Did you like this puzzle? Can you build the letter T with these 4 pieces? This is a classic puzzle originating in the 17th century called the T puzzle. When you put all the pieces together, you'll see that the resulting T is incomplete. You can try rearranging them, but the problem remains. Each T is always missing a part. So what's the solution? The key to solving this puzzle is to think outside the box. Usually, we place this piece horizontally, but then a problem arises. You'll see that when it's combined with the other pieces, it forms very strange angles that don't exist in a T. However, sometimes looking at the problem from a different angle can lead to a solution. You'll see that this piece has a right angle, which we need to utilize. What we need to do is place it like this, and then place another piece here. Now, we've built half of the T. We just need to place the other 2 pieces on either side, and a T will appear before your eyes. Do you like this puzzle? Can you put all 5 pieces into the sea urchin? This is a puzzle from Japan. As you can see, I can easily put all the pieces into the box, but the lid won't close, which isn't a solution. Of course, you can try swapping their positions, but the problem persists. The reason is simple. For example, a piece can be placed here, or it can be placed elsewhere, and its orientation can be changed. This means there are hundreds of different arrangements, but the puzzle only has one correct solution. You must find the exact position and orientation of each piece. So what is the solution? Let's test it. When the pieces are in the correct positions, the lid fits perfectly. One detail is that the lid also has different grooves. We need to ensure there are some gaps between the pieces so they can fit the shape of the lid. When all the pieces are in the correct positions, we also need to adjust the pieces to the right angle. Now the lid fits perfectly. Did you like this puzzle? Do you know how to put 6 cloves of garlic into this box? This is a puzzle from Japan in 2018. At first glance, it seems simple, but the problem is that even if you manage to put all the garlic cloves into the base, the lid won't close perfectly. You could try swapping their positions, since you don't know how they're supposed to be arranged initially. But the problem persists. The reason is simple. Each clove of garlic can fit into different slots simultaneously, and they are all very similar in shape. It's difficult to figure out exactly where it should be placed. We need to find the one correct solution from hundreds of incorrect arrangements. What we need to do is determine the position of the first one, but you don't know where it should be. So we need to test them one by one. This process requires a lot of patience to find the exact position of each clove of garlic, because they can fit into different positions. When they are all in the correct positions, you'll see the lid close perfectly. Did you like this puzzle? This is a very difficult, yet incredibly satisfying puzzle, where the goal is to fit all 22 pieces into a frame. This piece looks okay here, but it actually leaves a small gap that can't be filled later. As you can see, when the pieces are in the correct positions, they fit together perfectly. One particularly tricky part is that if you look closely, you'll notice that each piece has a unique shape, but the curves are very similar, offering no clues as to where they should be placed. However, there's only one solution to the puzzle. You must find the exact placement of each piece. I'm sure it will take you at least 2 hours to find the correct solution. The puzzle's design is inspired by the curves of a dragon, originally studied by NASA physicists John Hagway, Bruce Banks, and William Hart. The process of fitting the puzzle into the frame is incredibly satisfying and rewarding. They blend
Cancelaron
beautifully.
la salida.
But the most brilliant part is when you put in the
¿En
last
serio?
piece. It seems to disappear into the
Así que
frame.
podemos quedarnos a ver película juntos.
Do you like this puzzle? Do you know how to put 6 pieces into a box? This is a famous puzzle from 2012. When we're putting in 5 pieces, even if you see enough space, you just can't fit them in. You might try placing the pieces horizontally, but I'm here to tell you that won't solve the puzzle, because we can't add any more after 3 pieces. So, what's the solution? We place the first piece vertically on the left side of the box, then place one on top of it, in the same way. Place the third piece like this, and move it to the right side of the box. But the problem is that we can't add any more when we're putting in 4 pieces. We need to make good use of the space here. What you need to do is move this piece to the right and let it fall down. Next, move another piece here as well. Finally, place one piece and move it down. The remaining space will easily fit the last piece. Did you like this puzzle? Do you know how to make a Christmas tree with this chain? This is a puzzle from the US in 2010. You might think it's simple, and indeed, you'll find it goes very smoothly at first. But after a while, the chain no longer fits the base. You can try rearranging the chain in different ways, but the problem persists. The reason is simple. Some chains are in pairs, and some are in groups of 3. The puzzle has only one solution. You must find the exact position of each group of chains. But the problem is in the corner, where the remaining chains can be placed in different ways. This results in the remaining chains being placed along completely different routes. The correct solution is as follows. When the chains are placed here, we need to change our approach and start placing them from the top. Then continue placing them like this until you reach the corner. Now it seems the last chain no longer fits. But if we simply change their direction, we get a complete Christmas tree. Did you like this puzzle? Do you know how to remove the rope? This is a topological puzzle that has been around for hundreds of years. It has a very satisfying solution. At first glance, the only solution seems to be moving the rope along the loop. But the problem is that when you reach the end, you'll find you can't do it, because the exit is blocked by a ring. You might try flipping the rope and putting it into the ring, but then you'll find it's blocked by 2 balls. Moreover, the exit ring cannot be removed. The rope is trapped in the ring, and it seems there's no way out. But I want to tell you that the solution is extremely simple, without cutting the rope or breaking anything. Do you know what the solution is? All you need to do is move the rope to the ring. At this point, you need to think outside the box. Don't just move forward. Put the rope into the ring, and then stretch the rope. Next, flip the rope around and use its gap to go around the ring. And the rope is removed intact. Do you like this puzzle? Do you know how to fit the circular pieces into the frame? This is a classic 20th century puzzle that seems very simple at first glance. Just arrange the cuts of the pieces into a circle. But I'm here to tell you that doing it this way will never solve the puzzle. After trying, you'll find that you can't fit all the pieces into the frame. You can rearrange them in different ways, but the problem remains. There will always be one piece that can't fit. The reason is simple. We've fallen into the designer's mental trap. Solving the puzzle requires us to think outside the box. You must know a more efficient way to utilize the space. So what's the solution? What we need to do is place all the cuts at right angles, just like now. We do the same for the remaining pieces. The trap of this type of puzzle is that you don't have to adapt to right angles or perfect fits between the pieces. When all the pieces are rearranged, you'll see a square space formed in the middle of the frame. Are you satisfied with this solution? Do you know how to build a pyramid with 6 parts? This is a classic intelligence test from the 20th century. If you try to build it, starting from the bottom, after using 3 parts, the remaining pieces can't form a pyramid no matter how you arrange them. 4 of the parts have 3 balls, and 2 of them have 4 balls. You can try rearranging them in different ways, but each shape you create will look strange and not like a pyramid. The reason is simple. There are hundreds of different arrangements for the 6 parts. But the puzzle has only one correct solution. You must know the exact position and orientation of each part. What we need to do is first place one part here, Then, place a part with 3 balls here, and put another one on top of them. Next, you must use your imagination to place the remaining 2 parts like this here. And finally place the last part here, and the pyramid will appear before your eyes. Do you like this puzzle? Can you fit 4 T's into the frame? This is a classic puzzle from 1940. At first glance, it seems very simple because there appears to be plenty of space in the frame, but the last 2 T's won't fit. You can try rearranging them. After some time of trying, you might find a way to fit 3 T's, but most of the time, there isn't enough space for the last one. The reason is simple. When we place the T's along the edge of the frame, you'll notice that there's a lot of wasted space on both sides. You must find a way to use the space more efficiently. What's the solution? The trap in this type of puzzle is that it doesn't require the right angle or perfect fit. If placing them tightly against the edge wastes a lot of space, then what we need to do is place them diagonally in the corner. Then place another one here. Now there's still a lot of space left in the frame. We just need to place the third one here in the same way. Next, place the fourth one here. Everything fits perfectly. Do you like this puzzle? Can you put this star into the cage? This is a classic puzzle from the 19th century in the Czech Republic. At first glance, you might think it's an impossible task because the star is much larger than the gaps between the bars. It can't pass through the bars, and the holes at both ends of the cage are also not large enough for the star to pass through. But it's a puzzle, and you must find a way to solve it. So, what is the solution? There is an important detail you need to observe. The distance between the bars. If you observe closely enough, you'll notice that one gap is slightly wider than the others. This is the key to solving the puzzle. First, place the star here, then put the 3 spikes of the star into the cage. Next, try rotating it like this. When it doesn't move, try a different direction. You'll see the spikes go in more and more until half of the star is inside. You need enough patience, then repeat the action until you can fully put the star into the cage. This solves the puzzle. So, can you take the star out? Can you fit all the numbers from 0 to 9 into the frame? This is a puzzle from the UK called Count on Me. At first glance, you might think it's easy, but it's actually quite difficult. As you can see, you can easily fit the first 6 or 7 numbers into the frame, but towards the end, there are always some numbers that just won't fit. The reason is simple. For example, 0 can be combined with 1, and it can also be combined with 7. You can continue to place other numbers around them, but there's a tricky part. These numbers can be placed like this, or here, or somewhere else, or even different numbers can fit in the same spot. It's difficult to figure out how to arrange the pieces. There's only one correct solution, and you need to try and figure out the exact placement and orientation of each number, which can take at least an hour to solve. Finally, place 4 like this, and everything fits perfectly. Do you like this puzzle? Can you put cookies through holes in paper? No need to break the cookies in paper. It sounds completely impossible because the cookies are much larger than holes, and the cookies cannot be threaded through from any angle. But I'm going to tell you that you can do it with just a few simple actions. You can pause the video to think for a while. And I'm about to show you the solution. First, you need to use geometry to make a larger hole. The first step is to fold the paper lengthwise once. The second step is to fold the paper horizontally once. And the third step is to fold the paper diagonally once. Finally, open the paper and separate the overlapping parts. Now I'm going to ask you, do you think cookies can really be worn through? Let's do a test. We just need to put the biscuits in the middle of the paper and pay attention to the biscuits.